we entered into AC circuits, right? We discussed what is an alternating waveform. How do we characterize that, right? How do we characterize that? When I say characterization means what are the attributes which help us to identify what an alternating waveform is, right? And what were the attributes which we discussed last time? Tell me. What were the attributes which we discussed last time? We discussed this frequency, we discussed time period, we discussed amplitude, right? Now this slide was very important. This was amplitude, this was angular frequency, f is the frequency, phi is the phase difference, and we made these calculation. And then we came to one very important term known as average value. What do you mean by average value? Okay, so today we will see what do we mean by average value. Average value of an alternating waveform. What are the other names for it? Let us say the signal is f of t. Okay, so if somebody asks you average value, it is equal to 1 upon t f of t dt 0 to t. Okay, where ft is a periodic signal with time period t. Can I reframe this definition, mathematically definition? Can I write it like this? Anybody having any objection? If you have any objection, you please let me know. Is this acceptable? Is this acceptable?
Sir, theta equal to omega t, then uh, why have we written only t in the above formula?
Which formula? Here or here?
Yes, sir. In the first line, it should be omega t if we have replaced it by theta. Cos
Wait,
theta equal to omega t.
just look over here. Okay, I am changing the limits, right? I am changing the limits.
Yes, sir.
Now f of t, we may write f of t or f of omega t also we can write, no problem. Okay, like I write em sine omega t. So you can denote it as e of t also, or you can write it e of omega t also, no problem. Okay, only thing is that by writing omega you are showing that it is having a time period of capital T. Okay, mathematically if you want to get the convection, that also can be done. Okay, Why? See, what is t? T is equal to theta upon omega. These functions remain the same. Please try to understand. Ft is Em sine omega t, for example. Then whether you write it Em sine theta, theta being omega t, the function is not going to change. Are you getting my point? Only thing is that now we are reinventing the limits of the integration in the angular domain. Okay, is that okay, Aryan? Is that okay? For example, when t is equal to 0, theta is equal to 0. When t is equal to capital T, theta will be equal to 2 pi. You accept this or not? You accept
Yes,
this?
sir.
Yes, sir.
Okay. Okay. And t is equal to theta upon omega. So if t is equal to theta upon omega, what does it imply? Implies dt is equal to d theta upon omega, because omega is constant, implies that I have to replace, see, ft is equal to f theta and dt is equal to d theta upon omega. Okay, so omega into t, sorry, omega into capital T is equal to what? Omega into capital T, how much is it?
2 pi?
Omega into capital T, how much is it? It is 2 pi, right? Is that okay?
Yes, sir.
Okay, so this is clear. This is very clear. So now let us see some signals for which we intend to find the average value. Let me draw some signals. This is a sinusoid, crude approximation of a sinusoid. What is its average value? E of theta, tell me.
0.
Yes. E theta average is equal to 0. Very simple. Why?
Sir,
One way to
sir,
look at,
because the value is speaking in both the positive and negative direction.
yeah, the positive area and negative area are cancelling each other. The positive area and negative area are cancelling each other. Okay, so this is positive, this is negative, they are being cancelled. So in that sense, average value of every sinusoid is 0, every alternating signal. Now I give you, suppose, this signal. Now suppose I give you this signal. This is fully rectified sine wave. What is its average value?
Sir, EM.
You are too early to comment on it. Just think of it. I give you another waveform. This is half rectified sine wave. Please find out the average value. I am giving you 5 minutes. Please find out the average value. I will wait for you 5 minutes. Okay.
Sir, in the fully rectified sine wave, it is repeating after pi only, so its cycle should be of pi, not 2 pi. Then the average value should be em only.
You think of it now. Have you done? You have to do the integration, dear. Remember, average value is 1 upon t 0 to t ft dt. So you have to do the integration, no? I'm giving you 5 minutes. Please unmute yourself and then tell me the answer. I will like to hear from you instead of you just, you can post it, of course, you can post it on the chat box. That is very much appreciated, but I will like to hear from you also. I don't know how you are getting 2 2 You have to do the integration, dear. Without integrating, you will not get it. I am giving you 5 minutes. Anjali Rao is asking, sir, we will integrate from 0 to t. Either you, it's possible either way. I will do it both the ways. Whichever way you feel convenient, you can do.
Em by pi and em by 2 pi.
Come again, come again.
Em
Someone
by
said
pi
something.
and em by
Ayushman
2 pi.
Saxena. Ayushman Saxena, right?
Yes, sir.
Please tell me, dear.
So em by pi and em by 2 pi.
Good, 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 good. I will just show it to you how to do it. You are near exactly. See, for fully rectified, it will be 2 em by pi, and for half rectified, it will be em by pi. Okay. Good. Harshvardhan also very good. I will wait for other students also so that they can also post it. Amritanshu, very good. Okay. Jatin Dubey, you got it very good. Okay. One more thing I wanted to ask. Hello.
Yes, sir.
We need to conduct one mock test, right? Before the sessional. So please, and that too has to be done before, I guess, 2nd January, if I am not wrong.
Yes, sir, before second.
Before 2nd January, right?
Yes, sir.
So please suggest me a date. Latest by 2nd January. So when shall I conduct it? Tell me.
So give us time till 2nd January.
Okay, so you see, it's just a mock test, dear. Do not worry too much about it. Okay.
Okay,
And
sir.
but so so that you understand the whole process of the examination. Okay.
So how long will it be?
It will be only 1 hour, not more than that. And plus 15 minutes we will give you for uploading the.
Okay, mock test will be similar to the main exam, right?
So that you get acquainted with the process.
Okay.
So shall I take it on 1st January or tomorrow?
So 2nd January, right, sir? You told
2nd
2nd
January is the
January.
last date, but other teachers also might be conducting. Na? So it is, do not worry, it will not affect your marks in a way, just to give you a feel of the examination process. We are conducting that. So please suggest me a time. So let it be on 1st January.
Okay, sir.
Okay, let it be on 1st January. So please block your time. What time? What should be the time? Tell me.
Sir, tomorrow, is it fine?
For me, no problem. For me, no problem. Tell me.
1 second, sir.
But what should be the time? But
Sir,
what should be the
tomorrow, by my side, I'm just saying, we can confirm from others also. Uh, After the assignment class, we can have it.
Okay, no problem. But one thing you have to do during the mock test, there will be some differences between the actual test and the mock test. Mock test I will be conducting only once for the entire class, but the actual class test will be in group wise, not more than 21. And be careful that during the examination you must turn on your camera. Okay. Soham is calling 1st January is fine. So please let me know the timing of the mock test. Okay, we will continue with our discussion now. So many people have said 2 EM by pi, that's correct, and EM by pi, but how so? Let us see. Let us see that. See, is the screen visible? Is my voice audible as before?
Yes, sir.
Okay, now see, what do you mean by fully rectified sine wave and what do you mean by half rectified sine wave? The mathematical understanding has to be clear along with the graphical understanding. Please try to understand. See, my sine wave is this. E of omega t, if I call it Em sine omega t, okay, you have to be very clear when you write a sinusoidal function. Okay, you may write it like this, but see, the fully rectified sine wave, E fully rectified, what is it? What it is, tell me. How do you mathematically put it up? How do you define it?
Sir, omega t should be between 0 and pi by 2.
Yes, so you can write it in many ways. From 0 to pi it is plus Em sine omega t, and from pi to 2 pi minus Em sine omega t. You agree with me or not? Yes or no? This is minus Em sine omega t. Okay, and this is plus Em sine omega t. Why I have written like this? See, it's very important to understand, because your actual sinusoid is this and its mirror image is this minus Em sine omega t. So you should understand it like this. Okay, it's very important. Okay, because if you talk about periodicity also, some people will say, okay, its period is this, only pi, or it is having double the frequency of the original frequency. But it's not technically correct to say that. How do you mathematically put up things? If somebody asks you to write the expression mathematically, you cannot write it Em sine omega t, or you can write it at the best like this: EFR is equal to mod of Em sine omega t. Okay, is that okay? You understand what I am trying to convey? Yes or no?
Yes, sir.
So this is regarding the mathematical definition. Okay, now if somebody asks you what about half rectified sine wave, so you can say that from 0 to omega t it is plus Em sine omega t, and from pi to 2 pi it is 0. Okay, is that okay? Is that okay? Now coming to the derivation. Not derivation, average value of a half rectified sine wave.
Excuse me, sir.
Yes.
Sir, there will be only one mock test for all the subjects. I mean, for the whole exam, there will be only one mock test.
No, I don't think so.
Okay, I was just confirming, sir. Thank you.
I don't think so. I will be conducting, but okay. But the pattern will be same. See, the pattern will be same because it will be descriptive type. Your midterm one will be descriptive type.
So, sir,
if
we'll be having one each mock test for the 6 courses.
preferably, so you can contact your teachers. I will be taking. Okay.
Okay, sir.
But if you want an exact answer, that I will be able to tell you tomorrow only, because I cannot tell anything on others' behalf. Okay. But I will be conducting a mock test, and because there are instructions. Okay.
So what's the last date to conduct a mock? You said it's two for all subjects.
See, second, if you are insisting to confirm me right now, wait, I will confirm. Just wait for a while. Just
So
wait.
you can do it according to your comfort. It's fine.
What?
So you can confirm it whenever you want. It's fine.
No. You are asking. Now, just wait for a moment. Give me a minute. To confirm it now. Just give me a time.
Okay, sir.
Hello, am I audible? Hello.
Yes,
Yes,
sir.
sir.
Yes, sir.
See, I just had a word. Okay. So I will be conducting a mock test, but that will be for BET. Is that okay? Is that okay?
Yes, sir. Okay, sir.
Okay. And that will be for the whole class. In fact, you remember I posted an assignment on 9th of December. You remember or not? Okay. So it will be like that. But the point is that I will be taking for 84 students. Okay. So that will especially give you a flavor of what to expect in a sessional exam of BET. Is that okay? Is that okay?
Okay,
Yes,
sir.
sir.
But apart from that, on 4th January, you have already been divided into groups. Yes or no? Okay. In groups of 21, 22 like that. On 4th January also there will be a demo session. As I just had a talk with Deputy Director Academics who looks after all these things. Okay. First year actually. Okay. Is that okay? The confusion is clear?
So the demo will be for all subjects again or just one demo?
No. The demo will be general. Okay.
Okay, okay.
But since a mail came, so I will be conducting a mock test. Okay. Is that okay? And I think 1st January should be holiday, Aryan Bansal. Okay. So let us have the mock test on 2nd January. Is that okay?
Yes, sir.
Yes, sir. It's fine.
Oh, okay. So let us continue with our discussion. Okay. I will quickly do it. See, so how to find out the average value of a half rectified sine wave? E half rectified average. See, 1 upon 2 pi, 0 to 2 pi. E half rectified theta d theta. Now, from 0 to pi, what is E half rectified sine wave? It is Em sin omega t, right? Okay. And from pi to 2 pi, what it is? 0. So this is 0. And here you have 0 to pi Em sin theta d theta. So you get 2 by pi. Em can come out. Integral of sin theta d theta is how much? Minus cos theta. And that you have to integrate from 0 to pi. So you will be getting 2 Em upon 2 pi. So the answer will be Em upon pi. Okay. Em upon pi. Is that clear? Is that clear?
Yes, sir.
Yes or no? Yes or no?
Yes, sir.
Any doubts in this? So you can write it as point approximately equal to 0.3183 Em. Now average value of a fully rectified sine wave. How do you find that?
It will be twice the previous value. Twice the previous value.
That is logical, but if somebody asks you to show the derivation, how you will do that?
So instead of 0, we will write the 2 times the same integral.
See, that is correct. That is correct. But using the expression which I told you, Em sin theta d theta, right? And from pi, it's not that you have to do this way only. EM can be allowed to sit outside. So you will be getting 4 EM upon 2 pi. So it is 2 EM upon pi. So this is equal to how much? Tell me. You can call it approximately 0.6366 EM. Now I'll give you another waveform. Now, if somebody asks you to calculate the RMS value, what? Somebody please read it. What is the RMS value? Can somebody read it?
It is the value of current which, when flowing through a resistance, produces the same amount of heat as that of direct current flowing through the same resistance.
So this is important. Average value is compared with charging. Okay. And RMS value is compared with heating effect. Okay. So functionally, mathematically, how do you find that? This is the, if somebody asks you to find the RMS value of a function, you just do it like this: root mean of the squares. Okay. Or if somebody asks you to do it in angular domain, that also you can do it very comfortably. Okay. And there is another term known as form factor. It tells you, actually, it gives you the information, informs about the quality and fidelity of a given waveform with respect to the sinusoid. So this is the reference. Okay. Now there is another term known as peak factor. How do you define peak factor? It is maximum value upon RMS value. The significance of this is, it is helpful in safety design of the system. For example, you know that there is a cable, okay, which is carrying a particular current. So the conductor has to be designed to tolerate the peak value also. It is not only designed for the RMS value, it should be able to tolerate the peak value also. So another thing is insulation consideration of the design of for cables. Okay, is that okay? So these are some of the parameters which were important to be discussed, and we will end up our discussion for today in this context.